Yes, ladies and gentlemen, it's a pleasure to be able to give such a talk. I must admit it's my first experience being transmitted live over satellite. Normally you talk to a set of students in a classroom. Now I have to talk to my own face on screen. So let's see how that works out. What I would like to do with you is to discuss some recent developments in cartography and geovisualization, as we call it also. And especially I would like to concentrate on aspects of what we would call visual exploration. And during my presentation, I hope you will be clear of what is meant by visual exploration. Actually, I will try to tackle two major topics. That is how cartography partly evolved into geovisualization. And I would like to illustrate that with a case study. And I will demonstrate an example of a bit of history which happened in Europe. And after that I will discuss with you the latest developments in our field, which are called geovisual analytics. And again there I would like to demonstrate this with an example to improve the understanding. And in this case I will use a kind of a sports event as an example. In the introduction I will show you a few cases and examples of why it is necessary that we let's say go beyond the map, so to say, that we not just look at a static picture but look at an interactive dynamic picture, because nowadays we deal with lots of data, and especially India is well known for its satellites used for Earth observation, and they bring in loads of data every second, so to say, and we have to be able to process these data to get meaning from the data. And here maps can play an important role, and that's the role I would like to discuss. So let's look at a few problems we have in the world. What you see here is an animation of a single day of all airplanes flying through airspace on the globe. So it's obvious from this picture that you do not only see lots of planes, because every yellow dot represents one plane, but it's also clear that there's a temporal situation there. You might notice that at the moment in Europe we see lots of planes. There it's day, India is slowly getting to sleep, and the US is, when I'm speaking, waking up, and in a moment you will see an increased traffic at that particular location on the globe. China by now, in India, they are more or less asleep, and a few night flights are ongoing. So how do you deal with this type of data? Imagine indeed you are looking for a certain person. In which plane is he? Where is that plane? I mean, all kinds of questions you might ask. Or maybe you are in charge of Air India. Where are all my planes flying? And it would be interesting to be able to ask such a question and see dots in red appear, showing you where your own planes are, for instance. But again, it's the massive amount of data, it's the time factor involved, and these represent the type of problems we would like to solve. Another problem, and now we deal with a serious disaster type of problem, of flooding. In this case, on the right hand side of the image, you look at an animation of the Netherlands being flooded. As you will see, it's not the whole country that will be flooded, but most of it will be flooded. I will play it again, so you can see it again. Because we have to ask ourselves a few questions here. Because it is a simulation, happily. But is it a good simulation, and what kind of questions can be answered by such a simulation? I would ask you, okay, what area, let's say 10 meters above sea level, is under threat, then this particular animation can play a role, because it's based on a digital terrain model, so with height information on the country. And what happens in this algorithm, we simply fill the country, like if you would fill a bed tube, and at every meter you could stop and say, hey, which part of the country is now flooded, and then the next meter it's now flooded. It is not a good example to simulate when and where a disaster could happen, because probably a flooding would happen near riverbanks, or it would happen near the coastline. And as you will see here, and I will play it once more, it starts at the lowest point in the Netherlands, -6, and then it fills up. So if you look at simulations, animations, you always should ask yourself the question, for what purpose has it been created? Is it, and what story does it tell? And so in this case it tells the story of flooding, but it does not tell the story of the simulation in the sense of where could it happen. It's just what could happen and which area could be flooded at a certain sea level rise. So let's play again and watch carefully. It starts here in this area, the lowest point, and then it floods. But it has nothing to do with the natural occurrence of flooding. It's just filling up the terrain model, so to say. Another problem, so to say. In this case, we look at the map of France, and what we now will see happening is that the whole country is shrinking. And so the map on the left side already shows this shrinking, and I will play it again just to show you what happens. This is the case, and here we go. Now you wonder, what is being shown in this map? Why would a country shrink? It's not being washed normally. What happens is this is a map where the geographical base of the country is not the geographical space, so the area of the country, but it's related to travel time. So the map displays the time needed to travel from one place in the country to another. And it's based on the high-speed trains they have in France. So it shows you the situation, and again, I'll play it again, and I will stop it here at the beginning. So this is the normal France, and if you go from Paris to Marseille in the south, because of the train, it takes shorter time, and therefore they shrink the map. So it simply is another way of telling the story that because of the high-speed train network in the country, you can travel much faster through those countries. One more example. This represents the El Nino pattern in the Pacific and part of the Indian Ocean, and it shows you the currents in the sea. And of course you can imagine that blue is cold and the red is the warm water. And again, if I play it again, you will see that of course over time it changes, and we all now know that this pattern has quite an impact on the climate, on the local